Okay, see now, so it is being displaced. Slab. Small, it's a small, very small idea-based problem, nothing to do with that one. Huh? Okay, there's a slab like this. It is slightly displaced here. So, or I'll push it by distance x naught. So how much of, what are the forces that will be acting? Yeah, let's get into the forces. First, the electrostatic force, it will try to pull it into the plates. There's the one thing. So there's the one force. Then next again, the spring force should act here. Kx naught, and there's the external force. So I'll apply it, I'll release it. So this will be Kx naught here now. Okay, let's get into, is asking, prove that the slab will, a constant force applied, prove that the slab will execute simple motion, find its amplitude and time period. What do you mean by amplitude? From where to bring the amplitude? How much you displace towards right, there should be the amplitude, no? Because what is Fe? Any formula for Fe? F equal to half epsilon naught V square K minus 1 2D is that okay? I think if you remember this formula, lot of advantage. Any problem related to this, you can manage in exam. A epsilon naught, here it was capital E. Now what is the EMF of the cell? V, K minus 1 by 2D. So what is the value of K? Okay, it is 4, no? So therefore 4 minus 1. So this will become, okay, in the end we'll substitute, no problem. That is here K equal to 2. Spring constant, sorry, I think I'll make epsilon R because K is what we'll use for spring constant. Okay, there's a, look at this force. Irrespective of this position, this will be constant, no? This force will be constant. I apply a force. So this F is a constant. So this Kx naught will continuously increase. Then I'll push it. Go back to SHM. Then I'll release it. When I release it, this F is a constant and F naught will be there. So it's telling that a constant force F naught is applied to the slab as shown in figure. This will be the equilibrium position. Okay, now what will happen? There's an equilibrium. So I'll write it. So what is for equilibrium? Net force must be 0 at equilibrium. So what are the net forces now? F naught minus Fe minus Kx naught equal to 0. F naught is given. F is A into F naught V square epsilon R minus 2D minus Kx naught equal 0. So shall I call this as amplitude? This is nothing but amplitude. Go back to the SHM. If I further push it, I'll adjust the diagram. You can see now. Yeah, displaced. It's a purely diagram-based question. You can see now clearly. So some x displacement further I given. So how much spring will get compressed further by distance x? What is the total compression of spring? Will be K x naught plus x, and this is what Fe, and this F naught will be there like this here. So it was given further displacement. So what is the additional spring force? Only Kx, no? That is the restoring force. So about what point? About this point, it will vibrate. So this will become the right extreme, mean position, then you get left extreme. Like that, it will be oscillating. So therefore, restoring force will be only kx. So this kx should be equal to me. So it's a independent of what, like the dielectric slab. Epsilon r is we are taking, not k, that one. So don't get confused with the spring constant. Or if you want spring constant k naught, if you want, you can bring it. Okay, no, so very simple. So can be asked here. It's a purely diagram based. Now they may ask you what are other things. If there are more than one option, definitely I will try to stress other things. What are other things, like, okay, as it is executing SHM, whatever the work done by the cell. So as I push it, this F naught will be continuously will be acting. This F naught will be continuously, it will be acting here. This one. So what about the work done by the cell when it is oscillating? Will be, it does only positive work. It does only negative work. No, it does positive work as well as negative work. Potential is constant. Potential across the capacitor is constant. Capacitance decreases, so charge decreases. So as you start pushing this from this position, when it comes to this equilibrium position, no, so what happened to charge? Charge will go like this. So cell does negative work. Further, when you push it again, the charge will flow like this. Cell does negative work. The moment you release, the capacitor starts accelerating.